Much like degree measurements, radians are used to measure angles. In order to find the radian measure of an angle, we consider it in standard position at the origin as a central angle to a unit circle. And then to get the radian measurement, we look at the directed arc length in the counterclockwise direction of the intercepted arc. So for this angle, the radian measurement would be given by this arc length. An important thing to remember about the unit circle is that its circumference is equal to 2 pi. That means if we want to go all the way around a circle, we would need to go 2 pi radians. Now let's take a look at converting between radians and degrees. This should give us a better idea of how the two compare. We're going to use this comparison because 180 degrees is halfway around the circle. That means it's pi radians. So just think about that for a second. The total circle is 2 pi radians. So halfway around the circle is pi radians. And this corresponds to 180 degrees. Now let's convert some familiar angles. I want to start by converting 60 degrees into radians. And we're going to use this fact because there are pi radians per 180 degrees. So here's what we'll do. We'll take our 60 degrees and multiply by pi radians divided by 180 degrees. So the degree units cancel out. And what we're left with is 60 divided by 180. That's 1/3. And then pi radians. We also need to know how to convert the other way, from radians to degrees. So let's try converting 5 pi over 6 radians into degrees. And we'll do something very similar to what we just did, except now we're going to multiply by 180 degrees divided by pi radians. So luckily for us, the pi's and the radians cancel, and all that is left is to multiply 5 over 6 by 180. 180 degrees. And this comes out to 150 degrees. So this is another angle that you might have seen in the previous section. If we were looking at a unit circle centered at the origin and we looked at an angle in standard position, this angle would look something like this. Something else we might want to do is to find coterminal angles with radians. So remember, coterminal angles are angles that have the same terminal side, so they look the same, but their angle measurement is different, or might be different. So let's find angles in radians coterminal with pi over 2 radians. Let's look at a picture quickly. Again, we'll draw this unit circle centered at the origin, and then let's make this angle pi over 2 radians in standard position. And since the whole circle is 2 pi, pi over 2 is a quarter of the way around the circle. If we want to find a coterminal angle, we'll have to go all the way around the circle, either in the positive direction or in the negative direction. Let's do both of those. So pi over 2 plus 2 pi, going all the way around the circle in the counterclockwise direction. This will give us 5 pi over 2, once you find a common denominator. And then we can also subtract 2 pi to go all the way around the circle in the opposite direction, clockwise. And this would be minus 3 pi over 2.